Think of Neptune's rings like the discovery of penicillin by Alexander Fleming in 1929. At first glance, it seems like just another mold, but upon closer inspection, it revolutionized medicine. Similarly, Neptune's rings might seem like just another set of circles in space, but the truth is far more complex and intriguing. First, let's talk about the rings' names. Just like each groundbreaking medical discovery has its own significance and story, so do Neptune's rings. They go by the names Gale, La Verrière, Lasselle, Arago, and Adams. Yeah, the last name is a lot less exciting than the rest. That said, each one is like a unique chapter in a medical textbook, filled with its own set of mysteries and phenomena that beg to be understood. Now let's talk about composition. These rings are primarily made of ice particles, but they're covered in a dark, mysterious material. It's like discovering that penicillin not only kills bacteria, but has other, yet unknown properties. NASA has been investigating this, and they think that this dark material could be organic compounds or even space dust from micrometeorites. Each particle is like a molecule in this celestial medicine. We're still trying to understand its full effects. But here's an interesting fact. These rings are relatively young. They're not like the long-studied penicillin, but more like a newly discovered drug that's still undergoing trials. The James Webb Space Telescope has even revealed faint dust rings that were previously unknown. This telescope is like cutting-edge medical research, revealing new aspects of these rings that we didn't know existed. And it's not just about what they are made of. It's also about their structure. These rings have clumps and varying densities, making them unique compared to other planetary rings. The James Webb Space Telescope has provided us with images that show these irregularities in unprecedented detail, much like how advanced medical imaging can reveal the nuances of cellular structures. So just like the discovery of penicillin led to a revolution in how we treat bacterial infections, our understanding of Neptune's rings could lead to groundbreaking insights into planetary formation and the dynamics of ring systems. We've learned a lot, but each new discovery opens up more questions, more avenues for exploration, and that's what makes both science and the study of our solar system so endlessly captivating. Picture Wall Street, where traders are frantically buying and selling stocks. Now, in this chaotic scene, there are a few stocks that defy the odds. They're stable, high-performing, and everybody wants in. That's what Neptune's arcs are like. But here's the twist. These aren't separate stocks. They're more like exclusive sectors within a larger company's stock. They're part of the ring system, but they stand out because of their unique characteristics. So, what exactly are these arcs? They're dense clusters of material within Neptune's rings. Specifically, they're found in the Adams ring, one of the outermost rings. Imagine if Apple had a division that was outperforming all of the others. That's what these arcs are to the Adams ring. They're so unique that they've been given their own names: courage, liberty, fraternity, and equality. These aren't just random clusters. They're stable formations that defy our current understanding of physics. Now, you might ask, why are they stable? The James Webb Space Telescope has given us some clues. These arcs might be stabilized by tiny moonlets within the ring. Think of these moonlets as savvy investors who know exactly when to buy or sell to keep a stock's value high. They exert gravitational forces that keep these arcs stable, acting like market regulators in this galactic stock exchange. So we've established that these arcs are stable, but they're not stationary. Observations have shown that these arcs can shift and even trade places within the ring. This isn't a minor adjustment, it's a significant movement that challenges our understanding of gravitational physics and ring stability. The dynamic nature of these arcs has led scientists to explore various theories, including the influence of Neptune's moon, Galatea, and the possibility that these arcs are remnants of a shattered moon or comet. And let's not forget, these arcs are also young. They're like startups that have quickly risen to prominence and are still evolving. Studies suggest that these arcs are so new that their composition and structure are still changing. So just like understanding the intricacies of the stock market can make you a savvy investor, delving into the mysteries of these arcs could redefine our understanding of ring dynamics and gravitational interactions. We're talking about a celestial Wall Street. And this is one market trend you will want to follow closely. Imagine you're a detective with a complex case file in front of you. Each piece of evidence reveals something new, but you need to put them all together to solve the mystery. Neptune's moons are like those pieces of evidence, each one offering unique insights into the planet's ring system. What secrets do these moons hold? First on the list is Galatea. This moon is more than just a rock orbiting Neptune. It serves as a gravitational shepherd for the planet's arcs, particularly in the Adams ring. Its gravitational pull interacts with the particles in these arcs, stabilizing them and preventing them from scattering into space. The James Webb Space Telescope has provided data suggesting that Galatea's gravitational influence might be the reason why these arcs exist in the first place. It's like finding a fingerprint at a crime scene that matches a known suspect. Next, let's delve into Triton. This moon is a real oddball. It orbits Neptune in a retrograde fashion, meaning it goes in the opposite direction of the planet's rotation. This is highly unusual, and it suggests that Triton was captured by Neptune's gravity, rather than forming alongside the planet itself. Observations have shown that Triton has active geysers, making it one of the few geologically active moons in our solar system. It's akin to discovering a key witness, in your case, has a hidden past. Then there's Nereid. This moon has an extremely eccentric orbit, swinging far away from Neptune before coming back close. The JWST has even detected signs that Nereid might have its own faint ring system. This adds an unexpected layer to our understanding, like finding a hidden room in the house of a suspect. Finally, let's talk Proteus. This moon is irregularly shaped and is believed to be geologically active. Studies suggest that Proteus is slowly changing its shape, possibly due to internal geological processes. It's like realizing that your case involves not just people, but also rapidly evolving technology. So just like solving a complex case requires understanding each piece of evidence, unlocking the mysteries of Neptune's ring system demands a deep dive into each of its moons. They're not just a bunch of big space rocks. They're key players in a cosmic drama that we're just beginning to understand. Now imagine you're an art restorer, working on a masterpiece that's been damaged over time. You can see the brilliance of the original work, but there are missing pieces and faded colors that make the full picture unclear. What are the missing pieces in Neptune's ring system, and how do they fit into the larger picture? First, there's the mystery of the ring's composition. While we know that Neptune's rings contain a mix of ice particles and dust, the exact proportions and types of ice remain unknown. Researchers are keen to understand whether the ice is composed of water, methane, or other compounds, as this could offer clues to Neptune's history and the solar system's formation. Next is the enigma of ring stability. Unlike the rings of Saturn, which have existed for hundreds of millions of years, Neptune's rings are relatively young and may be temporary. What mechanisms are at play that determine the lifespan of a ring system? Could external factors like passing comets or solar winds be influencing their stability? Another unsolved puzzle is the varying brightness of Neptune's rings. Observations have shown that certain segments of the rings are brighter than others, but the reason for this is still unknown. Is it due to particle size, composition, or some other factor? This variability challenges our understanding of how ring systems evolve. Lastly, there's the question of undiscovered moons or moonlets. Neptune's system is complex, and researchers believe there may be smaller, yet to be discovered moons that could be influencing the ring system. These hidden actors could be the missing pieces needed to complete our understanding of this galactic masterpiece. So just like restoring a work of art requires a deep understanding of each missing piece and faded color, solving the mysteries of Neptune's rings demand a comprehensive look at each puzzling aspect. As we gather more data, we inch closer to revealing the full cosmic masterpiece that is Neptune's ring system. Next, imagine you're a scientist on the brink of a groundbreaking discovery, like Marie Curie when she discovered radium. You've got data, theories, and experiments, but there are still big questions that could change everything. In the same way, when it comes to Neptune's rings, we've gathered a lot of information, but there are still some big questions that could redefine our understanding, not just of Neptune, but planetary ring systems as a whole. First, let's tackle the question of origin. Where did Neptune's rings come from? One theory suggests that the rings could be remnants of a moon that was shattered by a comet or an asteroid. Another theory posits that the rings were formed from the leftover material after Neptune's formation. Understanding the origin could provide insights into planetary formation processes and even the early history of our solar system. Next, what's the deal with the rings' colors? Neptune's rings are reddish, unlike Saturn's icy white rings. The color could be due to organic compounds, or even complex ions known as polycyclic aromatic hydrocarbons. Say that 5 times fast. The exact cause is still unknown, and solving this mystery could offer clues into the chemical processes occurring in the outer solar system. Another big question is about the role of Neptune's moons in shaping its rings. We know that Galatea influences the arcs in the Adam's ring, but could there be other moons, perhaps even undiscovered ones, that play a role in shaping other features of the ring system? The answer could redefine our understanding of gravitational dynamics in planetary ring systems. And lastly, how do Neptune's rings interact with the planet's magnetic field? Unlike Earth, Neptune has a complex magnetic field that is tilted relative to its rotational axis. Could this unique magnetic field have an effect on the ring particles, perhaps even influencing their movement or composition? This is an area of active research and could have implications for our understanding of magnetic fields in planetary science. So just like Marie Curie's discovery of radium opened up new fields of research and changed our understanding of radioactive elements, answering these big questions about Neptune's rings could lead to groundbreaking insights into planetary science and the mechanics of our solar system. Each question is like a scientific experiment waiting to be conducted. And as we gather more data, we get closer to those groundbreaking discoveries. I hope you enjoyed this deep dive into Neptune's rings. If you enjoyed it, be sure to check out the video about high redshift galaxies on your screen now. These galaxies are like time travelers, giving us a glimpse into the universe's early days with their stretched out light. I know you'll love it, and I'll see you there.